Hi students, welcome to my lectures on thermodynamics. In today's lecture, we are going to discuss about finding out enthalpy of a reaction. As I told you, there are a number of methods to find out enthalpy in a reaction. One is directly conduct the reaction, find out how much heat or enthalpy that is liberated or absorbed during the reaction. The second method is to find out through enthalpy of formation. Third is to find out enthalpy of combustion, through enthalpy of combustion. In today's lecture, we are going to discuss about the first two methods, which is enthalpy of reaction directly and second through enthalpy of formation. To find out the enthalpy of the reaction, people use flow calorie-meter. It's a device where you conduct a reaction, find out how much amount of heat is absorbed or liberated during the reaction, and directly find out the enthalpy of a reaction. A flow calorie-meter is a device where you conduct a reaction. As I told you, the enthalpy of standard enthalpy of the reaction means you have to report the enthalpy of the reaction at specified temperature. Let us assume that specified temperature is 25 degrees centigrade or 273.15. I mean, example. For example, 273.15 Kelvin. Okay, for example, take. If that is the case, this is a flow calorie-meter. That means a specified amount of A and specified amount of B is sent into the calorie-meter and some product is coming out from the calorie-meter. Make sure the initials and final temperatures are the same. For example, if it is an exothermic reaction, heat will be liberated. The heat which will liberate will increase the temperature. Again, you reduce the temperature back to the specified temperature, which is 273.15 Kelvin. That means initial temperature and final temperature should be the same, so that either you have to absorb the heat or you supply the heat. If it is an endothermic reaction, you have to supply the heat. If it is an exothermic reaction, you have to remove the heat. The Q is nothing but enthalpy of this particular reaction. This is the simple flow calorie-meter people use to find out the standard enthalpy of the reaction. I told you, standard enthalpy of the reaction is represented by delta H T. This is degree. Okay, this degree is representing the standard state, which is taken as a pressure equal to 1 bar. The T means any temperature. Okay, if you wanted to conduct this reaction other than the 273, the temperature will going to change. If you want to conduct the reaction at another Kelvin, as 500 Kelvin, it is specified that enthalpy of the reaction at that particular 500 Kelvin. So the standard state, the degree always representing that you have conducted a reaction at 1 bar. As I told you, enthalpy is a very strong function of temperature, not with respect to pressure. So it doesn't matter what pressure you are dealing with, temperature is more concerned here. So for example, this degree is representing pressure equal to 1 bar. So this is the flow calorie-meter. People conduct the reactions and you are going to get the value of enthalpy of a reaction. Imagine you have conducted this particular reaction, CO2 gas plus hydrogen gas gives rise to carbon monoxide gas plus water gas. This is the reaction you have conducted in the flow calorie-meter. From this, the enthalpy, that means amount of heat, 41166 joule per mole CO2. That means because 1 mole of CO2 plus 1 mole of hydrogen gives rise to 1 mole of carbon monoxide plus 1 mole of water. That means if you conduct this reaction in a stoichiometric amounts, whatever the value you get, that is with respect to per mole of CO2 gas reacted or per mole of hydrogen that is reacted. The number here is positive, 41166. Positive means what kind of reaction is this? That is kind of endothermic reaction. Okay, that means you have to supply the heat. Okay, because endothermic reactions tends to reduce the temperature. To keep it back to this 273 Kelvin, you have to supply the heat. So that is why this particular reaction is an endothermic reaction. From this flow calorimeter, people have found out that the enthalpy of this reaction is 4116 joule per mole of CO2, which is endothermic reaction. So the thing is, there are millions of reactions, that are existing. People cannot conduct each and every reaction in this flow calorimeter to find out the enthalpy. What alternative method people have found is, you can measure the same enthalpy of the reaction using heat of formation data. Let us go to that method. What is this heat of formation data? From the heat of formation data, how you are going to get this enthalpy of this particular reaction. So the second method which I am discussing is enthalpy of reaction by standard heat of formation. What is the standard heat of formation? You know how the CO2 will be formed. C plus O2 gives rise to CO2. From that you get some, there is a formation data of CO2 you should require. Formation data of hydrogen is required. Formation data of carbon monoxide is required, and formation data of water is required. That means you should know them separately. Once you know them separately, then you can club in this reaction to find out what is the standard heat of formation of this particular reaction. For example, heat of formation of carbon dioxide gas, that means C plus O2 gives rise to CO2 kind of. From that reaction, the enthalpy of formation of CO2 gas at 273 Kelvin is minus 393509 joule per mole of CO2. To form CO2, this much amount of energy released. Okay. What is the heat of formation of hydrogen? Any diatomic gas like O2, N2, okay, H2, the formation data of a diatomic gas of same element, O2, N2, H2, the formation data of all these kinds of gases is 0, because they try to exist in the natural form, which is at H2, O2, N2. They wanted to exist in the same form. So formation data of this kind of gases, same element, atomic gases, that is always 0. That is why heat of formation of hydrogen is 0. Similarly, what is the heat of formation data of carbon monoxide gas is minus 110525 joule per mole CO. What is the heat of, last one is water. How water will be formed? The heat of formation of water from hydrogen and oxygen is minus 241818 joule per mole water. The heat of formation data of different molecules are already given. Many scientists worked out, they found out the heat of formation of different compounds. Okay, you can find out in the appendix of the book. These are the heat of formation data of all the molecules that is taking part in this reaction. Now, what is the enthalpy of the reaction? Always the enthalpy reaction is nothing but enthalpy of the products minus enthalpy of the reactants. Always keep this in mind. So enthalpy of this particular reaction is nothing but enthalpy of the products, that means these both, minus enthalpy of reactions, that means these both. So let us put together. I know enthalpy of my products, I know enthalpy of the formations of my reactants. Let us put it in this equation. What are my products? My products are carbon monoxide and hydrogen. That is why enthalpy of the products minus enthalpy of the reactants. My reactants are CO2 and hydrogen gas. Let us put all those values. I know CO, I know H2, I know formation data of CO2, I know formation data of H2, everything is listed. Why I have to substitute all these respective values in this formula, and by doing so I can able to find that from the heat of formation data, the enthalpy of this reaction is 41166 joule per mole of CO2 reacted, or joule per mole of hydrogen that is reacted. So you can take by, because this reaction is the same, you can able to find, you can represent in terms of per mole of CO2 or per mole of hydrogen, because everything is 1 mole. Okay. Otherwise, if you conduct the reverse reaction, then this will be my reactant, this will be my product. So if you do this, the number will be negative. if the forward reaction is endothermic, the backward reaction will be exothermic. So that is why if I conduct the reaction CO plus H2O gives rise to CO2 plus H2, you get a negative number. That is for this particular reverse reaction, then minus 41166 joule per mole of CO or per mole of water that is getting reacted in this reaction. So that is what we can able to go. Always remember, always remember the denominator. Okay, sometimes if 2 moles of CO2 is reacting in this particular reaction, that means you should divide it by 2. Okay, if the reaction is such a like that, because every 2 moles of CO2 getting reacted, this much amount of energy it is getting absorbed into the system. So for the that is why stoichiometry is very important. Here this is 1 mole, so there is no issue. I hope you understand now the simple method of finding out the enthalpy of the reaction using directly the reaction, or you can use the formation date of each and every molecule taking part in the reaction. Thank you very much. Let us meet with the new lecture. Thank you.